12 billion rounds are made every year, yet most people never ask why. The tiny round in your range bag grew from 19th century experiments into the backbone of training, sport, and industry. Its 300-year story hides engineering leaps, wartime demand, and quiet inventions that changed how America learned to handle firearms. The truth will surprise you. Fundamental terminology and classification systems. Caliber measures bore diameter, typically expressed in hundredths or thousandths of an inch in American systems, or millimeters in metric designations. A 308 caliber indicates a bore diameter of 0.308 inches. The 9 mm designation represents bore diameter of 9 mm, or approximately 0.355 inches. Groove diameter exceeds bore diameter by the depth of rifling grooves cut into the barrel. A 308 bore features groove diameter of approximately 0.3088 inches. This distinction matters for bullet selection and accuracy optimization. Cartridge designations often include additional numbers, indicating case length or year of adoption. The 223 Remington and 5.56x45mm NATO represent similar cartridges, with the metric designation showing 5.56 mm bullet diameter and 45 mm case length. The 30-06 Springfield includes adoption year 1,906 inches, its designation. The 45 ACP abbreviation stands for Automatic Colt Pistol, indicating original firearm design. These naming conventions lack standardization, requiring memorization rather than logical deduction. Bullet weight measurement uses grains, with 7,000 grains equaling 1 pound. A 115-grain 9 mm bullet weighs approximately 0.26 ounces. A 180-grain 308 bullet weighs roughly 0.41 ounces. Heavier bullets generally maintain velocity better at distance, but require faster rifling twist rates for stabilization. Lighter bullets achieve higher velocities but shed speed more rapidly through air resistance. Muzzle velocity indicates projectile speed as it exits the barrel, measured in feet per second. A 22 long rifle generates approximately 1,080 to 1,280 feet per second depending on load. A 223 Remington produces 3,000 to 3,300 feet per second. A 45 ACP reaches 830 to 950 feet per second. Velocity directly affects kinetic energy through the formula energy equals 1/2 mass times velocity squared. Doubling velocity quadruples energy, making velocity the dominant factor in terminal performance. Chamber pressure measures the force generated during powder combustion, expressed in pounds per square inch. The Sporting Arms and Ammunition Manufacturers Institute establishes maximum pressure standards for safety. Rimfire cartridges typically operate at 24,000 pounds per square inches. Pistol cartridges range from 17,000 pounds per square inches for 45 ACP to 35,000 pounds per square inches for 9 mm. Rifle cartridges reach 50,000 to 65,000 pounds per square inches. These pressure differences require appropriate firearm construction with steel types and dimensions matching expected loads. Rimfire ammunition categories and applications. Rimfire cartridges place priming compound inside a folded rim rather than using a separate primer cup. The firing pin strikes the rim, crushing the compound to create ignition. This design allows thin case construction and extremely light weight. The .22, short introduced in 1857, measures 0.423 inches in case length and fires a 29-grain bullet at approximately 1,000 feet per second. Total cartridge weight reaches roughly 27 grains. The design served early revolvers and small rifles for pest control and indoor target shooting. The .22 long rifle appeared in 1887, combining the .22 long case length of 0.613 inches with a 40-grain bullet. Standard velocity loads generate 1,080 feet per second and 130 foot-pounds of muzzle energy. High-velocity variants reach 1,400 feet per second and 200 foot-pounds. The cartridge costs approximately 4 to 6 cents per round in bulk packaging, making it the most economical centerfire alternative for practice shooting. Annual global production exceeds 10 billion rounds across all manufacturers. The .22 Winchester Magnum Rimfire emerged in 1959, extending case length to 1.052 inches. Standard loads fire a 40-grain bullet at 1,910 feet per second, generating 324 foot-pounds of energy. This represents more than double the .22 LR energy output. The cartridge serves small game hunting and pest control applications requiring extended range beyond 100 yards. Rifles chambered for .22 WMR cannot fire .22 LR ammunition due to chamber dimension differences. The 17 HMR arrived in 2002, necking down the .22 WMR case to accept 0.172-inch diameter bullets. The 17-grain projectile achieves 2,550 feet per second and 245 foot-pounds of energy. The extremely flat trajectory extends effective range to approximately 150 yards with minimal holdover. Wind drift remains the primary limitation due to the lightweight projectile. The cartridge costs approximately 30 to 40 cents per round, substantially more than .22 LR, but less than centerfire rifle ammunition. Centerfire pistol cartridges and performance parameters. 380 ACP, also designated 9mm Kurs or 9 by 17 mm, operates at relatively low pressure. Standard loads fire a 90 to 95 grain bullet at 950 to 1,000 feet per second, generating approximately 190 foot-pounds of energy. The cartridge fits compact pistols with overall lengths under 6 inches and weights below 20 ounces. Magazine capacity typically reaches 6 to 8 rounds in single-stack designs or 10 to 12 rounds in double-stack configurations. Recoil remains mild due to low slide mass and moderate pressure. The 9mm Parabellum, also called 9mm Luger or 9 by 19 mm, represents the most common pistol cartridge globally. Military and law enforcement agencies in over 100 countries issue 9mm sidearms. Standard pressure loads fire 115 to 147 grain bullets at 1,000 to 1,200 feet per second. Muzzle energy ranges from 320 to 400 foot-pounds depending on bullet weight and load. Modern pistols chambered in 9mm typically hold 15 to 17 rounds in standard magazines. Extended magazines reach 20 to 33 rounds. The combination of capacity, controllable recoil, and adequate terminal performance explains widespread adoption. The .40 Smith & Wesson emerged in 1990 from collaboration between Smith & Wesson and Winchester. The FBI requested a cartridge exceeding 9mm performance while fitting in medium-frame pistols. The resulting design fires 155 to 180 grain bullets at 1,000 to 1,150 feet per second, generating 400 to 500 foot-pounds. Magazine capacity typically reaches 12 to 15 rounds. Recoil exceeds 9mm by approximately 30 to 40%, affecting accuracy for some shooters. Adoption peaked during the 1990s and 2000s before declining as improved 9mm ammunition narrowed performance gaps. The .45 ACP appeared in 1905 for use in Colt's Model 1905 pistol. John Browning designed the cartridge to meet U.S. Army requirements for a service pistol cartridge. Standard loads fire 185 to 230 grain bullets at 830 to 950 feet per second. Muzzle energy reaches 350 to 450 foot-pounds. The large diameter projectile creates substantial wound channels, but limits magazine capacity to 7 to 8 rounds in single-stack 1911 pattern pistols, or 10 to 14 rounds in double-stack modern designs. Recoil remains moderate despite high energy due to low pressure and heavy slide mass spreading recoil impulse over longer duration. Centerfire rifle cartridges and ballistic characteristics. The 223 Remington originated in 1964 for Remington's bolt-action rifles before military adoption as 5.56 by 45 mm NATO. The cartridge fires 55 to 77 grain bullets at 2,700 to 3,300 feet per second depending on barrel length and bullet weight. Muzzle energy ranges from 1,200 to 1,400 foot-pounds. The relatively light recoil and flat trajectory make it suitable for varmint hunting, target shooting, and tactical applications. Effective range extends to approximately 400 yards for precision shooting and 600 yards for area targets. The 308 Winchester appeared in 1952 as a commercial cartridge before military adoption as 7.62 by 51 mm NATO in 1954. Standard loads fire 150 to 180 grain bullets at 2,600 to 2,800 feet per second. Muzzle energy reaches 2,600 to 2,800 foot-pounds. The cartridge serves hunting applications for medium to large game, competitive long-range shooting, and military-designated marksman rifles. Effective range for precision shooting extends to approximately 800 yards. Match-grade ammunition produces accuracy of 0.5 to 1 minutes of angle from quality rifles. The .30-06 Springfield gained military adoption in 1906, explaining the designation meaning .30 caliber adopted in 1906. The cartridge fires 150 to 220 grain bullets at 2,700 to 2,900 feet per second. Muzzle energy ranges from 2,800 to 3,200 foot-pounds, depending on bullet weight. The .30-06 served as standard U.S. military cartridge through World War I, World War II, and Korea, before replacement by 7.62 mm NATO. Civilian hunters favor the cartridge for versatility across game animals, from deer to elk and moose. Ammunition availability exceeds most other rifle calibers due to decades of military and commercial production. The .300 Winchester Magnum emerged in 1963, providing Magnum performance in standard-length rifle actions. The cartridge fires 150 to 220 grain bullets at 2,900 to 3,300 feet per second. Muzzle energy reaches 3,500 to 4,200 foot-pounds. The substantial powder capacity and high pressure generate significant recoil, measuring approximately 30 to 35 foot-pounds compared to 20 foot-pounds for 308 Winchester. Effective range extends beyond 1,000 yards for long-range competitive shooting and hunting applications. Barrel life averages 1,500 to 2,500 rounds before accuracy degradation from throat erosion. Shotgun gauge systems and load specifications. Shotgun gauge designation derives from the number of lead balls of bore diameter required to equal 1 pound. A 12-gauge bore accepts a lead ball weighing 1/12 of a pound. A 20-gauge bore fits a ball weighing 1/20th of a pound. Smaller gauge numbers indicate larger bore diameters. The 12-gauge measures approximately 0.729 inches. The 20 gauge measures approximately 0.615 inches. The 410 bore represents an exception, indicating actual bore diameter of 0.41 inches rather than following the gauge system. Birdshot pellets range from #9, shot at 0.08 inches diameter, to #2, shot at 0.15 inches diameter. A 12 gauge shell containing 1 ounce of #7, 5 shot holds approximately 350 individual pellets. These small pellets create dense patterns for flying birds and clay targets. Effective range remains limited to approximately 40 yards as pellets shed velocity rapidly. Pattern density decreases with distance as individual pellets spread across larger areas. Choke constriction at the muzzle controls pattern spread, with full choke providing tightest patterns and cylinder bore creating widest spread. Buckshot pellets range from #4 buck at 0.24 inches to 000 buck at 0.36 inches diameter. A standard 12 gauge shell holds 8 to 9 pellets of 00 buckshot or 12 pellets of #4 buckshot. These loads serve applications requiring penetration beyond birdshot capabilities. Effective range extends to approximately 40 to 50 yards depending on pellet size and choke selection. Pattern testing at intended ranges determines point of impact and spread for specific ammunition and firearm combinations. Rifled slugs provide single projectile accuracy from smoothbore barrels. A 12 gauge slug weighs approximately 1 ounce or 437.5 grains. Velocity reaches 1,400 to 1,600 feet per second depending on barrel length and load. Muzzle energy measures 2,400 to 2,800 foot-pounds, exceeding many rifle cartridges. Rifled slugs feature spiral grooves on the projectile exterior that engage barrel forcing cone for stabilization. Sabot slugs use plastic carriers that fall away after muzzle exit, allowing lighter projectiles to achieve higher velocities. These designs require rifled barrels for accuracy. Effective range extends to approximately 100 to 150 yards with quality ammunition and appropriate sighting systems. Specialty ammunition types and specific applications. Match-grade ammunition features extremely tight manufacturing tolerances targeting competitive shooting applications. Bullet weight variations remain within 0.1 grains across production lots. Case dimensions hold within 0.001 inches. Primer seating depth maintains consistent specification. These controls produce accuracy improvements, measuring 30 to 50% compared to standard ammunition. A rifle producing 1.5 minute of angle groups with standard ammunition may achieve 0.75 to 1 MOA with match-grade loads. The cost premium reaches 100 to 300% over bulk ammunition. Frangible ammunition uses compressed metal powder or polymer matrix bullets designed to fragment on impact with hard surfaces. The projectile disintegrates rather than ricocheting, reducing risks in training environments with steel targets at close range. Indoor ranges often require frangible ammunition to prevent backstop damage and reduce lead exposure. Velocities and weights typically match standard ammunition specifications. The primary disadvantage involves reduced terminal performance on soft targets due to fragmentation characteristics. Training applications accept this limitation in exchange for enhanced safety. Tracer ammunition incorporates a pyrotechnic compound in the bullet base that ignites during firing. The burning compound creates a visible trajectory path, allowing real-time observation of bullet flight. Military applications use tracers for signaling, target marking, and machine gun fire correction. Standard loading patterns alternate 4-ball rounds with 1 tracer. The compound adds approximately 5 grains to bullet weight and slightly reduces velocity. The burning material creates fire hazards in dry vegetation. Most civilian ranges prohibit tracer ammunition due to fire risk and regulatory complications. Armor-piercing ammunition employs hardened steel or tungsten core materials, penetrating barriers that defeat standard bullets. Military adoption remains limited to specific applications, including vehicle and aircraft armament. Federal law restricts civilian possession of armor-piercing handgun ammunition, defined as projectiles over 0.22 caliber, composed primarily of materials harder than lead with specific gravity exceeding steel. Rifle armor-piercing ammunition remains legal but faces limited commercial availability. Most shooters never encounter legitimate requirements for armor-piercing capabilities. Ballistic performance and trajectory calculations. Gravity affects all projectiles equally, creating downward acceleration of 32.2 feet per second squared. A bullet exits the barrel on an upward trajectory angle to compensate for drop at target distance. The line of sight through the optical or iron sights intersects bullet path at 2 points. The first intersection occurs during the bullet's upward flight path. The second intersection happens as the bullet descends to target distance. A rifle zeroed at 200 yards crosses line of sight at approximately 25 yards during initial rise. Bullet drop at 300 yards for a 308 Winchester, firing a 168 grain bullet at 2,650 feet per second, measures approximately 33 inches below line of sight when zeroed at 100 yards. At 500 yards, drop increases to approximately 141 inches or 11.75 feet. These figures assume standard atmospheric conditions at sea level. Elevation and temperature affect air density, altering trajectory. Altitude increases of 5,000 feet reduce drop by approximately 10% due to thinner air creating less drag. Wind drift perpendicular to bullet path creates lateral displacement. A 10-mile-per-hour crosswind causes approximately 9 inches of drift at 300 yards for the 308 Winchester load described above. At 500 yards, drift increases to approximately 42 inches. The effect increases exponentially with distance rather than linearly. Wind reading skills separate proficient long-range shooters from novices. Mirage observation, flag reading, and vegetation movement interpretation provide wind speed and direction information. Ballistic coefficient quantifies projectile efficiency in retaining velocity. Higher numbers indicate better performance. A round-nosed bullet produces ballistic coefficients around 0.200 to 0.25. Boat-tail Spitzer bullets reach 0.400 to 0.500. Very low-drag projectiles achieve 0.600 to 0.700. The calculation involves sectional density and form factor derived from projectile shape. Manufacturers publish G1 or G7 ballistic coefficients for match-grade bullets. These values allow trajectory prediction using ballistic calculators or software. Practical selection criteria and application matching. Training ammunition focuses on cost and volume over perfection. Affordable bulk rounds, such as 9mm at 20 to 30 cents each, let shooters practice more often, developing skill through repetition rather than firing small amounts of premium ammo. Standard ammunition provides enough accuracy for most training ranges, making expensive match-grade rounds unnecessary for short-distance drills. Competitive shooting varies. Bullseye events demand high-precision match loads, while action sports like USPSA only require ammo that meets basic power and reliability standards. In rifle matches such as PRS, consistency becomes critical, requiring top-grade cartridges built for long-range precision. Personal defense ammunition differs entirely, emphasizing dependability and controlled performance. Hollow-point rounds cost more, around 50 cents to $1, but are designed for consistency and reliability under pressure. Many shooters test with this premium ammo, then train with cheaper full metal jacket equivalents that mimic the same feel. Proper storage also matters. Ammunition kept cool and dry can remain reliable for decades, while heat and humidity shorten its lifespan. Ammunition choice isn't about chasing the most expensive round, it's about matching the cartridge to the purpose. Whether for training, defense, or sport, knowing what to use and how to store it is what truly defines a responsible and effective shooter.